Hey folks, welcome back. Today we'll be discussing about how to represent generic graphs, and the last time we discussed about adjacency list. I would like to add that this is an excerpt from a live session which held at DSC Banasthali.
Let's talk about how do we represent a graph. So a graph can be represented in four ways. The four ways which I know of, there can be more ways. First is adjacency matrix, adjacency list, a generic graph which say we want to make it entirely object oriented, and we want to put our other two representations on steroids and create something entirely different, encapsulated and whatnot. The next is adjacency set or disjoint sets. This is another way to represent graphs, and you would find these graphs and you would find these concepts in when you would have a bunch of graphs who have a cyclic nature, and then there is another bunch which has again a cycle. So you bunch them into a single graph and use disjoint sets there and use union on that. So this is out of syllabus for now, all right, because I haven't prepared it. Now let's put our graph representation on steroids and make it completely object oriented. So, excuse me, why would you want to do that? The main reason of wanting to create such a data structure is that your graph might not always be as simple as an adjacency list or adjacency matrix. So let's say that, let's take an example. We are creating a social network website, and you have just started writing some algorithm on your local. And what you do is you just, for the sake of simplicity and understanding, you just create an adjacency list. So let's say an adjacency matrix, because you realize you just have only a few members, maybe 100 members in your social network, and it's a closed-knit network. Everyone is connected to everyone. So let's just use adjacency matrix. It's just easy to maintain. Very good. Yeah, go ahead. Why not? So you do that. You create a matrix of Boolean type, and you add connections. However, now what you'll have to do is you'll have to make sure that the persons in that social network are just indices on that matrix. So you'll have to provide some hash code which will map those people to those indices in that matrix. Now, going forward, what you noticed was that, okay, every person is connected to every person. Now my thing is going good. I have around 1,000 members on my social networking platform. And you know what? Not everyone is connected to everyone now. And it's not very closely knit. I have people from other networks as well. And there's no connection between the two networks, which I have. So why not just use an adjacency list? So you change your code, you change your logic, you use an adjacency list. But again, what you'll have to do is, the way we were keeping track of our indices, you'll have to make sure that you can hash your indices, you can hash your people against your indices. Now, let's say from thousands you move to 10,000s and lakhs, right? And let's just assume we are still able to keep all that data in memory. So if you're still able to keep the data in memory, it might not be very optimal or useful to have it in adjacency list way, right? It may now make sense to make things more abstract. So when we are making things more abstract, what we do is we use edges, we use vertices, and we use graph objects. Now let's start with an edge. Every edge will have two vertices, vertex 1 and vertex 2. We'll We'll say whether it is directed or not. We will say whether it has any weight or not. And we will create constructors based on that. All right. So if you want to just put two vertices, just two vertices, vertices with whether it's directed or not with weight, for sure. Vertices with just direction, whether it is directed or not, sure. And then certain methods for adding, deleting edges. Now, what if we have to do it for vertices? What if we have to do it for vertices? Right now, every vertex should have a specific ID. Now, why do we need to have a specific ID so that a vertex can be identified? Usually, it is a hash code of the data which we are saving. And it also helps us to index our data in case we need to. So that we can just, rather than traversing through the entire graph, we can just go to that point and use that data and get information about that data, right? Now, every vertex will have a list of edges because there would be edges going out, coming in, right? And based on the direction we can identify whether the edges are going out or they're coming in, right? We can have the weight as well against these edges, and every vertex will have certain adjacent vertices, right? A list of adjacent vertices. So we would basically initialize a vertex with an ID because by initializing a vertex, we might not know what data we're going to put there, what are the edges, or what are the adjacent vertices which we'll have to add. So get ID, set data, get data. This is the part which is interesting. We add adjacent vertex. So in the current vertex, what we do is we provide an edge and we provide a vertex and we add that, right? And really, it becomes really easy because we just add our edge to the list and we add our vertex to the list, right? Now coming to graph. Now, what does graph? What does a graph have, right? So a graph will have a list of edges, and a graph will have a list of vertices, right? Because any graph, this let's move here. Any graph you notice will always have a list of vertices, and will always have a list of edges, and we'll know whether it is directed or not. Now, we initialize this graph, we initialize it, and then just adding methods. I'm not going deep inside it because it's just boilerplate, and most of the code is present in the GitHub link. So you can go ahead and find it out, check out the code, and write tests for it. If you are into Java and JUnit, why not write tests for it? I would very much encourage you to go and write tests and see if any of these data structures break at any point, or let's say if any of the code which I have provided you has bugs. Most probably it has because I haven't got a chance to test it thoroughly. Yeah.
All right, folks, that's it for today. Next time we'll be discussing about graph traversals. We'll be discussing about BFS and DFS. Thanks a lot.